Hi, Honors Algebra. This is 3.4. We're going to be talking about linear inequalities in two variables. With our objectives here, we're going to be determining whether ordered pairs are actually part of the solution to a linear inequality, and we're going to graph linear inequalities. Reminding you, when we're graphing linear inequalities, if we have a greater than or a less than symbol, when graphing, that's going to equal a dashed or a dotted line, depending on which type of line they give you. If we have a greater than or equal to symbol, or a less than an equal to symbol, then that's going to be a solid line, which means our solution is included into that solid line. Our dashed and dotted line, that actual line, is not part of the solution. It's either everything greater than the line or everything less than the line. So right now this is review, so go ahead, hit pause, and see if you can determine whether x equals 2 satisfies this inequality, and then come back and hit play and we'll go over it. Alright, so hopefully you worked on this. So if you go ahead, you are just pure substituting into wherever there's an x. And then to see if it satisfies this inequality, you're just going to go ahead and simplify. And this is -5 is less than -3. -5 is indeed less than -3. So because this is a true statement, we're going to say yes, x equals 2 satisfies this inequality. All right. For these two also, if you want to go ahead and review this on your own and hit play. So assuming you did that already, solve the inequality. We're just going to go ahead and simplify. So if I subtract 8x from both sides and subtract 1, I know that I'm going to get -4x is greater than or equal to -4. Here I have to divide by -4, but that should warn you that because we're dividing by negative, this sign, this inequality sign, flips to less than or equal to a +1. So there's our solution for there. Graphing this linear equation, you actually have two choices. You could plot an x and a y chart, or you could go ahead and find your x and y intercepts and then plot those and draw your line, which is the way I'm going to do. So remember that when you are looking for your x-intercept, your y value is 0. So I'm going to just use the cover-up method and write -10x equals -5. If I divide each side by -10, x equals +1/2. So my ordered pair is going for my x-intercept is 1/2, 0. So 1/2, 0 is right there, halfway between 0 and 1. For my y-intercept, that means my x value is 0. So if I just cover that up, I'm going to be left with 2y equals -5. So 2y equals -5. Solving for y, I get y equals -2.5. So my ordered pair for this y-intercept is 0, -2.5. This falls right between -2 and -3, halfway to be exact, on the y-axis. So I know those are weird because they're not integers, but it doesn't mean it's wrong. It just means that they're not integers. So we're just going to draw our line going through both points as best as you possibly can, and of course making sure arrowheads are in both directions. And that's it for the review, but we're going to show you now how to determine whether the given points are solutions to this linear inequality. So here we're given this linear inequality, and so we're basically going to rewrite our linear inequality and decide whether or not these ordered pairs are actually a solution to this inequality. So all I'm going to do is substitute in my values for x and y right in here. So x is -2, y is 3. So if I go ahead and solve this, I have -10 minus 6 is less than -3. Simplifying this further, -16 is less than -3. So in order for this to be a yes, because determine is a yes or no question, we have to see, is negative 16 less than negative 3? It is. Yes, it is. So it is part of the solution. Because this is a true statement. Okay? And all we're going to do the same thing for all of these. So if we go ahead and again just substitute in 1 for x, 4 for y, and simplify this, we have 5 minus 8 is negative 3. You got to be very careful here because they're asking you, is negative 3 less than negative 3? It is not. It's equal to negative 3. But according to this, they're asking if it's less than. So it's not. This is a false statement. So it's not a solution. This point, in other words, is not a solution. 1 comma 4 is not a solution to this inequality. All right. Last but not least, is negative 2, negative 4 a solution to this inequality? So if we substitute in negative 2 for x, negative 4 for y, are we going to get a true statement here? So negative 10 plus 8 is less than negative 3. Negative 2 is less than negative 3. This is false. Negative 2 is not less than 3. So this also is not a solution. So we only had one ordered pair here that actually worked, right? And watch out for the next video to go over the rest of section 3.4.